Hey guys, this is Coach Lowe, and we're going to talk a little bit geometry today. And we're in Chapter 4, Section 1, and we're going to look at classifying triangles. We're going to classify triangles by their angles, and then also by their sides. We'll start out just talking about how we're going to do that, and then we'll just get down to the nitty-gritty and we'll do it. All right, so let's talk about how to classify triangles by their angles. All right, so classifying triangles by their angles. So we have four different ways that we can classify triangles, or four different types of triangles that we'll be classifying, maybe is a better way to say it. First, we'll have a triangle where all the angles are acute angles. Let's see if I can get one going here. I've got one that you could probably see the outline. No, okay. Try it again. There we go. All right, so here is an acute triangle. All the angles here are less than 90 degrees. But if I put some measurements on here, and let's say that I tell you all of them are 60 degrees, although it is an acute triangle, this is also called equiangular, which means all the angles are equal. So the name will kind of help you there just a little bit. All right, another type of triangle would be an acute triangle. So let's get all of these angles so that they are less than 90 degrees. So notice what I said, all angles less than 90 degrees. So when I look at these three angles, I'm just going to make sure they're less than 90 degrees. And yes, so this is an acute triangle. So angles are all less than 90 degrees. All right, so you could probably guess what the other two are going to be. Have any guesses for me? Yep, that's one of them. All right, so we'll go with an obtuse triangle. An obtuse triangle has one obtuse angle. So we have an acute angle. Over here, three acute angles in this little acute triangle. And then I have an obtuse angle here in this triangle, and it measures over 90 degrees. So obtuse triangle has one angle that is an obtuse angle. All right, then the last one would be a right triangle. A right triangle. So guess what? One of the angles is going to measure, 90 degrees. Bam. Usually that angle will be marked like so, but this will be a right triangle, and it has one right angle. The other two will be acute angles because the other two have to add to be 90 degrees. Yeah, they have to be complementary. So, yep, you got it. All right, so that's how you classify triangles by their angles. Let's talk about how to classify them by their sides. All right, so let's talk sides here. Come on, pen. There we go. All right, so by their sides, we're going to look at three different ways. Either all three sides can be the same length, so equilateral, and you'll notice usually they'll either have measurements or remember those little reddish, pinkish marks that they give you like this. And so this tells me that it's equilateral. Lateral is side, like lateral movements would be side-to-side movements. So equilateral triangle. So all sides are the same measure. So if this is 6 meters, then this would be 6 meters, and this would be 6 meters. They don't even have to write that. If they tell you it's an equilateral triangle and give you one side length, then you know all three side lengths. All right, so isosceles triangle, which looks like this yellow one up here, that's my acute triangle. If I mark those two sides equal in measure, then this would be an isosceles triangle. So this is an isosceles acute triangle, or an acute isosceles triangle. So you can do sides and angles at the same time. Kind of cool, huh? So this is isosceles. Two sides are the same length. So two sides are congruent. All right, and then a scalene triangle. Scalene is the last one we're going to look at. A scalene triangle has no sides that are the same length. And I totally meant to have a line there. Now you can see how crooked I can actually draw, which you guys totally already know that. No need to comment there. No need to comment. All right, so here's my scalene triangle. All sides are different lengths. This is scalene. All different lengths on the sides. All right, so that's the 3 ways to classify triangles. So we have isosceles, 2 sides that are congruent. We have equilateral, all 3 sides are the same measure. And we have scalene, where all 3 sides are different measures, different lengths. All right, no congruent sides on that scalene triangle. All right, so let's look over here. Let's see if we can classify these 4 triangles by their angles, since we see angle measures here. Let's see if we can do that. So let's make this one number 1. Looking at these angles, I'm checking for a right angle or an obtuse angle. Otherwise, I know it's an acute triangle. So I have a 30, an 85, and a 65. Those are all less than 90 degrees. So this is an acute triangle. Moving to number 2, you guys can go ahead and pause the video and see if you can do these last 3 without me. So go ahead and pause it and we'll be right back. Did you really pause it? Or are you just waiting for me to continue? Because if you didn't really pause it, then pause the video. All right, so now that we're back, obtuse triangle. Obtuse triangle, because I have an obtuse angle, there's an angle that measures greater than 90 degrees. All right, triangle number 3. I see a right angle. It says 90 degrees. It doesn't have the marking, but it's a 90-degree angle. So this is a right triangle. And then the last one that I see is all the angles are the same. So this is equiangular. All right, so there are the 4 triangles that we have classified by their angles. All right, this next triangle is kind of weird because there's several triangles in this one. But let's see if we can classify these different triangles. Let's look at triangle ABD. Triangle ABD. All right, so do you see the triangle I'm talking about right here? All right, so can you classify this triangle by its sides and by its angles? Well, I can see by the sides, there are markings on all 3 sides, 1 mark on each, which means they're equal, right? So equilateral. And doesn't really tell me about the angle measures, but you will learn as we move forward that on an equilateral triangle, the angles are all also equal. So like on this equiangular triangle, the side lengths are the same, all the same measure. An equilateral triangle, all the angles will be the same measure. We'll come back to that. All right, let's move on to the next triangle that I want to look at. Let's look at triangle BED. Triangle BED. Triangle BED. So let me get over here and see if we can kind of trace that out. BED. There it is. And I see double markings here and double markings here and then a single mark here. So what does that mean? That means segment BE and segment ED are congruent to each other. So I have 2 sides that are congruent. So identifying this or classifying this by its side lengths, if I have 2 sides that are equal to each other, it's what type of triangle? What was that again? Yeah, isosceles. Yeah, good job. All right, so I have an isosceles triangle. And then what about its angles? Well, we'll also learn this too. These angles that are opposite these congruent sides are congruent to each other as well. So I have 2 angles that are congruent to each other, but that doesn't really help me classify it, but we'll learn that later. But I do notice that both of those angles that I just marked are both acute, and this one right here appears to be what? Yeah, obtuse. So one of the things that I like to look at when I'm classifying is if I come off of this angle E right here, or point E, and I try to make a right angle, so try to make a segment that's perpendicular to this one. Do you see this one is bigger? Like that goes bigger than 90 degrees right here. So that is an obtuse angle. So this is an obtuse triangle, obtuse isosceles triangle, obtuse isosceles triangle. All right, let's do one more, and then we'll be finished with this guy. Let's look at EDC. And there are several triangles we could look at, but we're going to quit right here. So let's look at EDC. I see this right angle is marked here, so I know I have a right triangle. 2 marks, 1 mark, no marks means none of the sides are equal to each other. So triangle EDC is scalene. EDC is scalene right triangle. Right, so it's a scalene right triangle. All right, hope that makes sense. Let's keep moving here. All right, so the next one, triangle LMN is an isosceles triangle with LM congruent to LN. LM is 3x minus 2, LN is 2x plus 1, and MN is 5x minus 2. And we need to find the side lengths of this triangle. So let's go ahead and draw a picture. You guys knew I was going to say that, right? Probably already drawing because you know what's coming. All right, so isosceles means I have two sides that are congruent. All right, so the legs of this isosceles triangle are congruent to each other. By the way, this is the base, and these would be the base angles that we'll talk about later that are congruent to each other, but it's always good to locate the base because you know we're all about the base. Yeah, exactly, you got it. All right, so LM and LN are congruent to each other. So notice I put the L up here because it's common to both of these side lengths. So I'm going to put it at the top. That way I can run right down the sides of this triangle. And LM is 3x minus 2. LN is 2x plus 1. And the base is 5x minus 2. All right, so we do know that. How cool is that? Okay, so we do know that LM and LN are equal to each other. They're equal in measure. They're congruent. The sides are congruent. So I know that 3x minus 2 is equal to 2x plus 1. And so I can solve this now, this equation for x, and then I can find out the values of my side lengths. The missing piece is the value of x. Without it, I don't really know how long LM and LN are. I know that they're equal to each other, but I don't know their length. So I'm going to subtract 2x from both sides. You guys know how to roll this from here. So if you want to pause the video, you can go right ahead and finish up. I'm going to subtract 2x from both sides. So x minus 2, I'm floating here. X minus 2 equals 1, or x is equal to 3 once I add 2 to both sides. All right, so when x is 3, how long are these sides? So I have 3 times 3 minus 2. So 9 minus 2 is 7. So I have 7 for this side. I should get 7 for LN. Let's see if I do. 2 times 3 is 6 plus 1 is also 7. And then I need to know the base. Remember, the base isn't the same length, and it shouldn't be. So 3 times 5 minus 2, or 5 times 3 minus 2. So 15 minus 2 is 13. So now I know all the side lengths. Side LM is 7, side LN is 7, and the base MN is 13 in length. All right, another type of problem that they might give you, and I'll go ahead and start this one, and then I'll let you finish this because you'll have one similar to this on your activity. So a problem that they could give you is one like this, where they say, graph these points, find the lengths of the sides, and then identify what type of triangle this is. So you would graph these guys. So negative 3, 2 tells me to go left 3 and then up 2, and that's point K. Point P tells me to go right 2 and up 1, and that's point P. And then point L tells me to go left 2 and then down 3 for 2, negative 3, and that's point L. And then we'll connect those guys. And there's our triangle. And then we want to find the lengths of those sides. Now, you know as well as I do, we cannot go by looks because, first of all, you can see my spacing on my graph is awful. All right, this looks like it could be equilateral, possibly isosceles, but until I have those numbers, I don't really know. So I have to find the length of KP, the length of PL, and the length of KL. So do you remember from the last chapter how I do that? Exactly, I want the distance formula. So I want the distance between the points K and P. So remember, I do x2 minus x1 squared, Pythagorean theorem, right? So I'm going to do x2 minus x1 squared. So 2 minus negative 3 squared. Why that's coming on there. 2 minus negative 3, and then I'm going to square it. Thank you. And I'll change these to addition signs, so that's going to make a 5 in just a second, isn't it? Plus, and then let's go y2 minus y1. y2 minus y1. So 1 minus 2, and then square that. So I end up with the square root of 5 squared plus negative 1 squared. Well, 5 squared is 25. 1 squared is 1. So 25 plus 1 is 26. So I have the square root of 26 for KP. Now, it's up to you if you want to put that on your calculator. You definitely don't have to. You can leave it just like that. Square root of 26. So then I would go through that for PL and KL, and then I would compare the side lengths. If I get 3 different answers, then I know this triangle is scalene. If I get 2 answers that are the same, then I know that this is isosceles. If all 3 are the same, then I know that it's equilateral. All right, guys, hope you enjoyed the video. And if you have any questions, make sure you ask. This is Coach Lowe, and I'm out.